Okay, hello everyone. I welcomes to all in our lecture series on conversion of numbers from one system to another. In this lecture series, we are discussing these topics, which are most essential for B.sc, B.Tech, M.sc, M.Tech, and various entrance examinations. In our last three classes, we discussed these three topics. In this class, we are going to discuss decimal to hexadecimal and hexadecimal to decimal conversion. Okay, so let us start. These things already we have been discussed in our last three classes. Fractional decimal to binary conversion in detail we discussed. Then fractional octal, octal to decimal, fractional decimal to octal, these things in detail we discussed. Last class we discussed octal to binary conversion and binary to octal conversion. Binary to octal conversion. Okay. Okay. In this class, we are going to discuss decimal to hexadecimal conversion and hexadecimal to decimal conversion. So here hexadecimal means 16 numbers, that is your 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. These are the 16 numbers belongs to hexadecimal number system. Okay, but in digital electronics up to 9 it is represented as the like this. Up to 9 it is represented as number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But from 10 to 15 it is represented as letter. 10 number represented as A, 11 B, 12 C, 13 D, 14 E and 15 F. Okay, you just remember these things. Now we consider a decimal number, that is your 536. We are trying to convert this decimal to hexadecimal. Here the procedure to convert any decimal number to hexadecimal is same as we discussed conversion of decimal to binary and conversion of decimal to octal. In case of conversion decimal to binary, each time we divided 2 by the given decimal number. In case of decimal to octal, each time divided by 8 with the given decimal number. In this case, we have to divide 16 each time. Okay, until any one of these number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 will come up as quotient. When any one of these number will come up as quotient, then our process will be stopped. Okay, so let's do this. First, this 536 divided by 16, we can get the quotient as 33 and remainder will be 8. Then it will be divided by 16, we can get quotient as 2 and remainder will 1. So here we got 2. Here we have to stop our process or division with 16. Now we are going to write the hexadecimal number of this decimal number. How? From bottom to top. From bottom to top, that is your 218. So here given decimal number is 536. It is represented as subscript by 10. Its corresponding hexadecimal number is your 218 subscript by 16. Now we are going to verify, is it so? That means this 218 number, what we tell that it is the hexadecimal number of this decimal number, that we are going to verify. Okay, consider this one 218, which is the hexadecimal number. If we are going to convert this hexadecimal to decimal, what we have to do? See, this is your LSB, least significant bit. This is your most significant bit. The least significant bit will be multiplied with 16 to the power 0. May you remember when we converted a binary number to decimal, we multiplied the least significant bit with 2 to the power 0. For conversion from octal to decimal, we multiplied 8 to the power 0. So here from hexadecimal to decimal, the least significant bit multiplied with 16 to the power 0. Then 1 will be multiplied with 16 to the power 1, 2 will be multiplied with 16 to the power 2. Now we are going to just add these values. We can get 536. So hence it is verified that this is the hexadecimal number of this decimal number. Okay, now we are going to go for another decimal number, that is your 44,808. Now we are going to convert this decimal to hexadecimal. Okay, so what we have to do, we have to divide it by 16. We can get 2800 as quotient, corresponding remainder will be 8. Again divided by 16, we can get quotient as 175 and corresponding remainder will be 0. Again divided by 16, we can get 10 and corresponding remainder will be 15. So here we got the quotient as 10. That means here one of the number of the hexadecimal number system. So here we have to stop our process and we are going to write the number, hexadecimal number, from bottom to top. 10, 15, 0, 8, this one. But this is not exact representation of hexadecimal number of this decimal number. Then what is the exact representation? Instead of 10 we have to write A, instead of 15 we have to write F. So exact representation or accurate representation of the hexadecimal number of this decimal number is your, instead of 10 it is written as A, instead of 15 it is written as F. So AF08 subscript 16 is the representation of hexadecimal number of this decimal number. Now we are going to just verify. Here we considered AF08, the least significant bit is your 8 and the leftmost number is your, or letter is your most significant bit. Least significant bit will be multiplied with 16 to the power 0, then 0 will be multiplied with 16 to the power 1. F, here F means 15. Okay, F means 15. 15 will be multiplied with 16 to the power 2. A means 10 will be multiplied with 16 to the power 3. Now we are going to just add these values. We can get the same number, 44808. Okay, here we have been verified. Now we are going to go for a fraction decimal to hexadecimal. Here the given fraction decimal is your 44808.37. We have to convert this one to hexadecimal. In our previous slide we converted this one, this number, this decimal number to hexadecimal, and we found the answer is your AF08. Now we are going to convert this fraction part, that is your 0.37, to hexadecimal. This is the procedure of conversion of fractional decimal to hexadecimal. What it is? The fractional part will be multiplied by 16 each time until integer part will come as 15 and fractional part will come as 0, where integer part taken as answer. If 15 not came after 4 to 5 times iteration or multiplication, then we have to take optimum iteration or multiplication or approximation. This is the procedure. By considering this procedure, we have to find out the hexadecimal number of this fractional decimal part, that is your 0.37. Let's do this. So what we have to do here, given fractional part is your 0.37. Here the fractional part will be multiplied by 16. First multiply 0.36 multiplied with 16, we can get 5.92. For 5.92, 5 is your integer part, 0.92 is the fraction part. Here we have to multiply 16 each time until integer part will come as 15. Here integer part came as 5, okay, and fraction part came as 0.92. Integer part taken as answer, that means 5 will be the answer written separately. Then same step we have to do, that means 0.92 will multiplied with 16 again. Why? Because here we got 5.92. If we got 15, no, then we are not going to do again multiplication. As we got 5.92, the fraction part 92 0.92, again it will multiply with 16. So how much we can get? We can get 14.72. 14 is the integer part, 0.72 is the fraction part. 14 is our answer written separately. Again we have to do the same. 0.72 multiplied with 16, we can get 11.52. 11 is your integer part, 0.52 is the fraction part, 11 is our answer written separately. Again 0.52 will be multiplied with 16, we can get 8.32. 8 is your integer part, 0.32 is your fraction part, 8 is the answer taken and written separately. Like this, we can do the multiplication or iteration for optimum approximation. Here I consider the 4 iteration or multiplication that we have to check after 4 iteration or multiplication how much answer we got. Okay, how much answer we can get after this 4 multiplication or 4 iteration. If it is approximate to value, then we have to stop, or we can consider this is our optimum iteration. If it is not approximates to the value 0.36, 0.37, then we have to again consider the iteration. Here after 4 iteration, what will be the answer? Answer will be written from top to bottom. That is your 4e b8. See here we have tried 4, 14, 11, 8. 14 is represented as your e, 11 is represented as b. So only for that it is written as what? 5. Here 5, instead of 14 written as e, instead of 11 written as b, 8 as such it has been written, right? So the answer, final answer will be AF08.5EB8 subscript with 16. Conversion of this decimal number to hexadecimal number, and the hexadecimal number will be this much. Now we have to just verify. Here already we know that if we are going to convert this hexadecimal number to decimal, we can get this one. We have to just verify this number 0.5EB8. How much we are going to get? We have to just check it. 0.5EB8. So what is the procedure to convert hexa to decimal, hexadecimal to decimal? Here 5 will be multiplied with 16 to the power minus 1, then e will be multiplied with 16 to the power minus 2, b will be multiplied with 16 to the power minus 3, 8 is multiplied with 16 to the power minus 4. We have to just add these values. Here further, after further calculation, here 16 can written 1 by 16 to the power 1, 1 by 16 to the power 2, like this. So you just calculate it, you can found the value will be 0.3698 is approximate to 0.37. So here we found when we converted this hexadecimal number to decimal, we found this value. Approximately we can say 0.36. So here we can consider that this 4 iteration or these 4 steps are enough for this question. Okay, enough for this question. Suppose after this these 4 iteration we got the answer, suppose 0.298. That means it is not approximate to 0.37. Then what we have to do? We have to do further iteration. That means up to 5 or 6 iteration we have to go. Okay, here after 4 iteration we got the answer, so here we have to stop. So yes, here I am going to stop our today's class. In our next class we are going to discuss hexadecimal to binary conversion and vice versa. Okay, thank you so much for watching this video. Thank you.